Basically, you're looking for the cracks, anything else in the bottom of it. I'm not so concerned with the outside edges of it, as we talked about yesterday. I'm more concerned with the bottom. The outside edges, as much as we want these to be nice, they don't always, some labs crack them and break them and still want to continue using them. I've seen them put lab tape around them and everything else. If that's what they choose to do, I'm not going to question their ability. That doesn't affect any of my testing. What will affect the testing is the interior of the vessel. And again, you don't want no cracks on the bottom. You don't want any dropped paddle blades causing any spidering at the bottom. Any one of those things, any scratches, anything else. Usually if you hold it up to light, you can see whether there's any cracks or any nature inside there. Anything that's on the inside of it that you can feel with your fingernail is going to impact any kind of chemical testing. The chemicals will get stuck inside the trough left by the scratches and is going to impact the chemical testing. So you want to make sure that, I always bring it to the attention of the lab manager, hey, this has got some serious scratches in it. It'd behoove you to replace this. If you don't want to, that's on you. And if you want me to continue the testing, I will. If I'm doing chemical testing, I'll tell them that I don't know if I can pass it with those scratches in it. Usually if you say you don't know if it can pass, they'll usually get another vessel for you. But again, that's part of the inspection process. Next thing is inspection of the vessel covers. Pretty self-explanatory. Whether you have the old acrylic ones that fold together, you need to check the hinges on them, or you need to check the integrity of it, make sure that it's working fine. With this one here is basically just to make sure that it's still pliable. It still has the centerpiece that attaches to it. This is what the centerpiece is that goes up inside there, and make sure that's still nice and that the O-ring that's on top of there is still working good and that both of these are still attached. Inspection of the RTD shafts. You're basically just looking at the integrity of the shaft itself, making sure that it's not completely, we can already see there's a wobble on that, and we'll adjust that during the wobble adjustment portion of it. And that happens during the MQ. But in the preventative maintenance, you're just making sure this is intact. It looks like everything's attached to it, all the wiring's attached, everything's working the way that it's supposed to be working. Inspection of the calibration probe, making sure that it's plugged in. Some of them plug in, some of them are hardwired in. This one's hardwired in. I'm making sure that there's no frayed cables on this. Nothing looks like it's out of the ordinary. It's not bent here. And a lot of times they bend right here and they cause a crack, and you can see bare wires inside there. Making sure the probe itself is not bent out of whack. Verification of smooth travel of the shaft. So I just got done lubing this, and that's what we're talking about, the smooth travel of the shaft. This should go up and down nice and smooth. It shouldn't be having a yank on it. I've had some that are so old and haven't been lubed in years, but when you lift this, it actually lifts the head up. So you want to make sure that it can go up and down smoothly. Let's see, inspection of the basket adapters and paddles. That goes without question. I don't have the apparatus with this one, but as we talked about yesterday, key things, paddle blades, you're just checking for nicks and scratches. Every one of these, you can see, it's stainless steel, nice, shiny, reflective. If it's a Teflon coated, obviously you're looking to make sure the Teflon coating's not nicked and scratched. But even the stainless steel, you want to make sure there's no big nicks and scratches in it, because they can happen. You can drop these things, they hit another piece of metal, you can get a nice scratch or a nick in it. That could cause some impact to the hydroponics of the hydrodynamics of each one of the vessel positions when it's spinning around with a chemical inside of it. So these need to be inspected. The basket adapters, one of the big things. Obviously checking and making sure there's no scratches or whatnot in it. Making sure that this hole that's on the top of it, that's for releasing the bubble, is not plugged with any material. There's a hole that's on the top of this. You gotta make sure that that's open and it allows the bubbles to escape. Making sure that your basket, as I was telling you, you weren't here yesterday, but I was showing you guys, it looks like a little cylinder. That's all you want to make sure, that it looks like it's cylinder. That this end is over this end. Sometimes you'll see that they're bent a little bit, the wiring is bent, and you'll see like the hole is like off center. And a good way of knowing that whether it is or not is rolling it across a flat surface. If you roll it across a flat surface, you can look at one side here and watch it and see whether or not it's oscillating. If it's wobbling, you got a problem with this. Or if this bends way too easy, so after time these become very pliable and easy. That's not going to do you no good either. And then last but not least is to take, I usually put my finger inside here and rotate it, feeling for any imperfections. If there's any stray wires that are sticking out, that's going to cause problems also. So you just want to make sure that there's, and spin it both ways, because sometimes you don't, maybe it's a little tiny one, you're not catching it, but if you spin it both ways, if it grabs into your finger, you know you've got a stray piece of wire sticking out. So that's for inspecting this. And the last thing for these is to make sure they attach to these. They should attach and stay up there firmly. You can use a little force and pull them off, but you want to make sure it goes on there nice and neat. If it doesn't, that O-ring inside here may need to be replaced. And that's what you're looking for. Inspection of the shaft collars. So on this one here, that's just to make sure that these things are intact, that they have the screws, that they're tight, that they're not moving around any. They don't go up and down, they're usually tightened down where they need to be. You may need to adjust the height later, but we'll get to that when we get to the MQ. That's part of the MQ section. Inspection of the vessel sintering arms. This is for a 61 and 6300, so there's no vessel sintering arms on this. The vessel sintering arms are these that you'll see on the 6100, the bathless technology. This here is a vessel sintering arm, and this is good for a 63 and a 6100 document. You're not going to see many 61, well, you have 6100s, right?
I don't think so.
No, I think you did. He did. Yeah, okay. This is your vessel sintering arms. You see on bathless units.
Okay.
So that's what it's talking about on there. If it doesn't have them, it gets innate. Yeah, it's basically it holds the vessel in place. There's two things that hold the vessel in place on a bathless unit. One is the heater jacket itself. Sometimes these get, with the heating and cooling cycles, tend to make it contract. And if it does contract, the way to make it a little bit looser is to make the spring. I usually take the spring and pull it out a little bit to make it a little bit looser. It doesn't need to be so stiff that it makes it hard to pull this thing up and down. And then simply take this off and make sure that each one of these bends. And these things have a tendency to break off one side or the other, the tab, and then you have to replace it. It's just a small common screwdriver goes in the middle there. It's just a tiny Teflon screw. Take that screw out, put it back in. It's a matter of replacing it. It's just the tab that breaks off.
Just this one.
Yeah, we got one on one. It's just one piece, but what'll happen is one side or the other usually has a tendency to break off. So you're checking for the integrity, making sure that it still holds it and that it bends back and forth. And once it's inside there, it should hold it pretty firm. That's the inspection of the vessel sintering arms, which this one doesn't have, because this is a 6300. So this one here, it has inspection of the vessel sintering ring. As I talked about yesterday, I don't want this, I got water in it.
Oh.
I got one over here.